of a ultrasonic frequency generator, either may be magneto or electro, and CRO, cathode ray oscilloscope, transmitting transistor A and receiving transistor B, and amplifier. So from this point we will give the ultrasonic waves. So if they are coming from by taking this much time, so there is no flow, there is no defect in the material. But if they are coming early than this point, this time, then there is some defect in the metal. So depending upon this time taken from this transmitter and receiver, depending upon the time difference between the transmitter and receiver, we can easily find out what is the defect in this specimen, in this metal. Next, the working of this inflows, there is a change of medium. So this produces the reflection of ultrasonic waves at cavities or cracks. So the reflected beam is recorded by using CRO. The time interval between the initial and flow echoes, it depends upon the range of flow. So by examining the echoes on the CRO, the defect of flow can be detected, or their size can be estimated with the help of CRO echoes. So features, this method is used to detect flows in all the common structural metals and other materials like rubber tubes, etc., rubber tire, etc. This method is very cheap and of high speed of operation. They can easily check with the help of machines, and it is more accurate than radiography. Second use in the engineering is drilling, ultrasonic drilling. So ultrasonic waves, they can use for making holes in very high materials like glass, diamond, etc. For this purpose, a suitable drilling tool bit is fixed at the end of powerful ultrasonic generator. This one is generator of ultrasonic waves. So here we put a bit for the hole which is required to drill a hole here in this metal, in this hard material. Some slurry like a thin paste of carbonundum powder and water is made to flow between the bit and plate in which the hole is made. So ultrasonic generator causes the tool bit to move up and down very quickly, and slurry particle below the bit just remove some material from the plate. This process continues and hole is drilled in the plate. So this is second application of drilling. Third one is the application of welding. So ultrasonic waves can also be used to weld the different materials. Like the properties of some materials, they change on heating, and therefore such metals cannot be welded by electric or gas welding. In such case, the metallic sheets, they are welded together at room temperature by using the ultrasonic waves. For this purpose, a hammer H is attached to a powerful ultrasonic generator as shown in figure. So next is metallic sheets to be welded. They are put together under the tip of hammer. So these two are sheets which we need to weld, A and B. So we put these two sheets below this hammer. The hammer is made to vibrate ultrasonically. As a result of this, it presses the two metal sheets very rapidly, and the molecules of one metal, they diffuse into the molecules of other metal. So this in this way we can weld the two materials. So and it will not produce any heating in the material. This process is also known as cold welding. Next example is soldering, ultrasonic soldering. Metals like aluminium, they cannot be directly soldered. However, it is possible to solder such metals by ultrasonic waves. An ultrasonic soldering iron consists of ultrasonic generator having a tip fixed at its end which can be heated by electrical heating element. The tip of soldering iron melts solder on the aluminium, and ultrasonic vibrator removes the aluminium oxide layer. The solder thus gets fastened to clear metal without any difficulty. Ultrasonic waves can be used for cutting and machining purpose, and they can also be used for the cleaning purpose. So, we can easily cut and machine different type of material with the help of ultrasonic waves. Next application is ultrasonic waves can be used to clean the different materials like our jewelry. We can easily clean with the ultrasonic waves. It is a most cheap technique employed for cleaning various parts of the machine, electronic assembles, armatures, watches, etc., which cannot be easily cleaned by other methods. So, next application is sonar. Sonar, the full form of the sonar is sound navigation and ranging. It uses ultrasonic waves for the detection and identification of underwater objects. This method consists of sending a powerful beam of ultrasonic waves into the suspended direction in water. By noting the time interval between the emission and receipt of the beam after reflection, the distance of object can be easily calculated. The change in frequency of the echo signal due to Doppler effect, it helps to determine the velocity of the body and its direction. So, depending upon the time, measuring the time interval t between the transmitted pulses and received pulse, we can easily find the distance. D is equal to V into T upon T2. V we know it is fixed for the ultrasonic waves. Time we can easily calculate from the time interval between the transmitted and received pulse. So, we can easily find the distance. Same principle is used to find the depth of the sea. So, we know we can easily find the time interval between the transmitted and received pulse. Velocity we know for the sound waves or ultrasonic waves. So, V into T upon 2, this 2 factor is because of the total path is double. So, application of sonar, it is used for the location of shipwrecks, submarines on the bottom of sea. It is also used for fish finding application, and it is used for seismic survey. So, now we will discuss what are the application of ultrasonic waves in medicines. So, first one is diagnostic sonography. Medical sonography or ultrasonography is a ultrasound based diagnostic medical imaging technique that are used to visualize muscles, tendons and many internal organs, their size, structure and pathological lesions. They are also used to visualize fetus during the routine and emergency prenatal care. Ultrasound scans, they are performed by medical health care professionals. They are called sonographers. So, obstetric sonography is commonly used during pregnancy. So, next medical application is ultrasound therapeutic applications. They are treating different type of disorders and tumors. So, these procedures they generally use lower frequency than the medical diagnostic ultrasound. They require only 250 kilohertz to 2000 kilohertz, but it is significantly higher time average intensity. So, time interval is more, but the frequency is less as compared to the diagnostic ultrasound. So, more powerful ultrasound sources may be used to clean the teeth in dental hygiene, or the generate local heating in biological tissues, for example, in occupational therapy, physical therapy and cancer treatment. Extracorporeal shock waves lithotripsy uses a powerful focused ultrasound source to break up kidney stones. Focused ultrasound sources may be used to contract treatment by using emulsification. Doppler ultrasound is being tested for use in aiding tissue in the treatment of stroke sufferers. So, this procedure is called ultrasound enhanced systematic thermolysis. Ultrasound has been shown to act synergistically with antibiotic in bacterial cell killing. So, next application is ultrasonic blood flow meter. Ultrasonic waves can be used for studying blood flow by measuring the change in their frequency produced due to Doppler effect. The physiological effect of ultrasonic energy, they are the mainly two issues like enhance inflammatory response and it heats the soft tissues. So, ultrasound energy produces a mechanical pressure wave through a soft tissue. This pressure waves causes the microscopic bubbles in the living tissue and distortion of cell membrane, influencing the ion fluxes and intracellular activities. In some cases, it also causes small pockets of gas in the body fluid or tissues to expand or contract. The long term effect of the tissue is heating and cavitations, they are not known. So, last some other example in the other fields, the application of ultrasonic is that ultrasonic guidance for the blind. Ultrasonic waves, they are used for guiding the blind who carries a walking stick containing a ultrasonic transmitter and receiver. Ultrasonic signal, they reflected from any object, they are fed to the headphone through a suitable electronic circuit which enable the blind person to detect and estimate the distance of the obstacle. Ultrasonic waves, they are used in research. Scientists often use in research, for instance, to break up high molecular weight polymers. So, ultrasound also make it possible to determine the molecular weight of the liquid polymers to conduct other form of investigation on the physical properties of the materials. They can also use in agriculture that seeds subject to the ultrasound waves, they may germinate more rapidly and produce higher yield. So, this is the interaction of the ultrasonic waves with the matter. We know they can easily get reflect, scatter and absorb through the matter. So, next is work problem. A quartz crystal of 1 mm, its thickness is 1 mm, it is vibrating at resonance. So, we want to know the calculate the fundamental frequency. So, P is 1, Y Young modulus is given 7.9 into 10 raised power 10 and rho is 2650. So, F is equal to P upon 2T Y upon rho. So, P is 1, T is 1 mm, it means 0.001 meter and Y is 7.9 into 10 raised power 10 and rho is 2650. So, after calculation we will find the frequency is 2.73 megahertz. So, next is the simple question. Ultrasonic waves is high frequency sound waves and it is above the range of human hearing, it is more than 20,000 hertz. Ultrasound waves can be used to measure the distance, for example in sonar. They can be used to obtain the scans, for example the developing baby within the mother womb. The ultrasound waves can also be used to clean object. So, very high frequency waves of ultrasonic sound, they can use to shake off dirt or grease like this way. So, we can use ultrasonic waves in many purpose like cleaning, medical, etc. Thank you.